Okay, we're going to be looking at 6.4.2a. This is going to be sort of a review, so it's all familiar. Right now we're looking at the methods and learning. List synonyms for slope, and it says that there's going to be 3, so I think that's going to be m for slope. There's also going to be like growth number or growth value. And then there's also change in y over change in x. Man, I cannot spell change, or maybe I'm just changing the way I spell change. And you know, there's also like rate, and there's like the word per. You see that a lot, or each. All those go together. So many choices. I'm just looking for 3, but all those are good. That's not what I meant to do. I meant to do that. Okay, cool. Here we are, y-intercept. Of course, the y-intercept is usually the b. It's also the start number or start value. It's also the y value when the x value is 0, the hero. Okay, that is not French. That is just bad typing. There we are. All right, cool. So that's it for part A. B, describe the graph of a system that has no solution. So if there's no solution, that means like the 2 lines never crossed, right? Because the solution is where they cross. So they never cross, which means they must be parallel. What is going on with the typing today? It's not funny. Parallel. Alright. I just do that to feel triumphant when I can't type. It kind of gets rid of the embarrassment. Alright. The graph of a system that has all real numbers as a solution. That means like that no matter where you go on the line, it's a solution. That means the lines touch each other everywhere. So the lines touch each other everywhere. Keep your minds clean. So they're basically the same line. It's like 2 hearts beat as 1. The relationship of the slopes when the lines are parallel. So if 2 lines are parallel, like, you know, imagine there's this line going this way and then there's another one going this way and they're parallel, well, their slopes move exactly the same direction. So their slopes must be the same. And the relation of the slopes when they're perpendicular. So now we have one that's sort of going like this and another one going like this. This one is not as mathematically obvious, but we have discovered it before. The slopes are opposite reciprocals. An example is if the first slope, we'll just call it m1, equals 3 over 4, then m2, the second slope, equals -4 over 3 because it's opposite reciprocal of the other slope. So like if we have a 3 over 4, then the other one you take the reciprocal and you make it negative, and those lines will be perpendicular. All right, so that's for B. C, name 2 forms of linear equation. That's simple. There's a standard, which looks like ax plus by is equal to c. And then there's slope-intercept. And that would be y equals mx plus b. Really important stuff. Okay, list the methods for solving linear equations and the best times for using each method. First one we learned was the equal values method. A little space right there. Equal values, that's when you have 2, it's not 2, that's a 2, 2 slope-intercept. I didn't mean to do that either. That was weird. I meant to do copy, and instead I just wrote a C over them. So they're probably gone now, so I'm going to have to write that again. Oh, sleep, sleep, sleep. Y equals mx plus b. And I got that right. Okay, I'm going to copy it instead of just writing a C over it. Oh, way nicer. Okay, so when you have two of those, then you'll do equal values. Okay. Second, there's substitution. And you'll do that when you have one slope-intercept and one standard. And we remember this because when you have one slope-intercept, you can take the expression that is equal to the y, and you can replace the y in the standard with that expression. So like it would be ax plus mx plus b equals c. And yeah, that works pretty well. Okay, and the third one is called elimination. And elimination is when you have two equations that are in standard. And little reminders that when they're both in standard, you either get the coefficient of x or the coefficient of y to be opposites of each other, and then you add the two equations together, and one of the variables disappears, allowing you to solve for the other variable. All right, so that's it for our methods in learning today. Just all reminder type.